Hello, how y'all doing today? My name is Bernie Thompson. Today we're here to take a look at this 2015 Hyundai Genesis. This Genesis has a problem with the dash where all the lights are illuminated on the dash, and if I rev it, I have no tach and I have no mile per hour if the vehicle is driven. So that's our complaint. Now, the shop that brought this in has already replaced the dash, and obviously it didn't fix it because I believe this probably has a bus error. One of the buses in this vehicle is probably down, and that's why the dash isn't able to talk. So the first thing I want to do is I want to get a scan tool in this vehicle, and I want to just pull up some really basic data so we can try to figure out what's wrong with this vehicle. So let's go ahead and get that scan tool connected. I've got the scan tool and we pulled up the data. We went in and we queried a general scan of all the modules so we could see. We have the electronic stability control has 10 faults. Let's just take a quick look at this one. You want to look at trouble codes. Okay, so now we have history codes for the CAN buses and timeouts. This is telling me that the bus is timed out because it has errors. And we have an active code right here where the CAN bus is in an off state. So this is telling me that the high-speed CAN, C-CAN, has a problem. Now, one of the things I really want to do is I want to go get the gateway. Should be in the data to display somewhere here. Here we are. Here's the gateway. We have 7 faults in the gateway. Now the gateway is going to have all of the data. It's going to have low and high speed, and it's going to be able to tell me a better idea of which bus is down or if multiple buses are down. Okay, here we've got a history code CAN, history on CAN, history, but in active again, the C-CAN bus, and this is a bus, is down and it is active, so it says this bus is off. So right now is what I know is I know that I have a bus failure on this vehicle. There's something wrong with one of the buses. So what I want to go ahead and do is I want to get a wiring diagram out, and I need to see how the topology of this system is in operation. How are all these modules in communication with each other, and what bus structures are they using? Are they using low speed, a CAN medium speed, CAN high speed in order to communicate? So let's go ahead and get the wiring diagram and take a look at how the topology of this vehicle is operating. I have the wiring diagram up for this Genesis. Now the first thing I always like to do is I always like to find the DLC, the 16-pin pinout that goes into the computer. Now we know we're looking for a CAN C or a high-speed CAN bus. Traditionally those are pinned off of 6 and 14, but I can see right away pin 14 doesn't even have a wire going to it. Now I want to caution everyone, when you work on a Hyundai or a Kia product, a lot of times the DLC is not wired as it is in the wiring diagram. And it doesn't matter whether I'm using a diagram from an OE or Mitchell or ALLDATA, they're just not wired sometimes correctly. Sometimes I have to pull this connector out and actually look at the wire colors and where they're connected. But right now I know I don't have a traditional high-speed CAN. But I can also see where I've got pin 3 and 11, and that's usually a medium speed bus, but on some CAN, or on some of these Hyundai Kia systems, that can be a CAN high bus. So I want to go ahead and we want to follow these wires down, and we can see this white one comes into the bridge, and we have a breakout right here, and we've got these two, the white and the black, and we're going to follow those up here, and they're going to go up and they're going into a gateway. Now I want to show you, see where this white and black go in? They go to a DCAN high and DCAN low. And the DCAN means it's diagnostic on CAN. Now, diagnostic CAN is a way that I can separate the DLC from the interface. What that means is, this is an engineering strategy. So if you're an engineer, one way would be to be directly on the bus like Ford would be. Ford's bus systems are wired directly from the DLC directly into the CAN bus, and they're hardwired. Now what that does is if I plug in a scan tool, it can disrupt the bus and I can set codes or have problems. Now Ford deems that that's okay, but other manufacturers want to isolate the DLC from any of the bus structures, and you do that by diagnostics on CAN or DCAN. The diagnostics on CAN will only go in to the gateway. It doesn't go out of the gateway. And then we have all of our other systems that are also operating through the gateway or the bridge. Now when I come down, I can see here that I got CCAN and CCAN, and that is a brown and a white wire. Now these are the bus structures that's down. So what I want to do is I want to come down and I want to come across, and we can see that this is going to go out 1 and 2, and here we've got 1 and 2, and we're going to come up here, and this is with lane assist, without. I have lane assist, so it's going to come up through the connector and it's going to drop down out of the connector, and one of them is going to go to the lane assist module out of this pack. Now these packs right here, these splice packs, those are CAN splices, so those are really used for diagnosing the car. So if I unplug this, I break the system into components. Now, if I know where these are, it's way easier than going and finding all of these modules and unplugging the modules independently. If I can unplug it and I have a bus problem and I can plug it or unplug it, I can get an idea where the problem might be. Now, we don't know what's wrong with this car right now, but that's what these are about. These are splice packs so I can break the bus structure in pieces. Now, I also come back out and I'm going to go into this splice pack, and now I'm going to come up into the ECS, that's the brake unit, the right blind spot, and notice how the left blind spot talks to the right blind spot, and then the right blind spot, it's the one that's on the bus. And a lot of systems operate like that for blind spot detection. One unit talks to the other. I see that on many different makes and models. Now I also see that I've got these wires coming out of this connector right here, these two, and they're on 3 and 4, and they're going to come back up into, let's see, 3 and 4 right here, and they come across and they're going back down into this connector right here, and this connector is one of the splice brakes, and it goes up and it goes to the electronic parking brake, and that's in the rear, and then it comes over and it's also going to go into this junction here, and we're going to go to the smart cruise, and then we come out of this structure right here and it's going to come over, and now we go to 25, 26. So we come down over here, and that's these bus wires that come down also at the bottom, 25, 26. So let's find that. They come in right here, 25, 26, and they go into another splice pack or a CAN brake where I can diagnose this. Now out of this one, it comes up into this unit, and then they come across, and I got another brake, but this one comes over into the ESC again, and then we come up here and we come across, and that's 13, 14. So we're going to come over here to 13, 14, and we come across and we come up into this brake, and now we come into these modules right here, and then we splice out right here and we come into the steering module, the angle sensor, and we also go down here and we also come across here. So we go to 1 and 2, so we're going to go down here to 1 and 2, and now we come up and we come into more splices, and we come over into the SRS, or the airbag module. And then we have the splice come down here as well, and we come out 11, 12. Okay, so that's going to go back up to in here. We got 11, 12. We come into the middle. And these come down here, and this is going to go to the instrument cluster. So the instrument cluster has got high speed and a medium speed bus in it. So both units are here. Now what I've seen by going through this data right now and the way that the topology is laid out is if I put a breakout box and I go through the DLC, I will not be on the bus that I'm concerned with. I'm on CCAN. I need to be looking at a CCAN bus. The wires that come out of the DLC are how we're talking or communicating, and we already saw the scan tool can communicate with the bridge or the gateway. So if I put a breakout and I think that I'm on the bus and I look at those signals, I'm going to have good signals. So be really careful. You always got to understand the topology whenever you're working on one of these systems. So if you went and you looked at the breakout box and you look at the signals off of it, you're making a vast mistake. You're not even looking at the bus structure that you need. In order for me to easily get into the bus structure I want to get into this instrument cluster, and I want to get into the low speed and the high speed. And since I've already got the dash loose and they've put it in, I want to go ahead. It'll be easy for me to get access into these wires, and then we can look at this with a scope and try to figure out if we have a bus problem or not with a scope. So really at this point, to move forward, we need a scope. But I do want to make one more note here that's really interesting, and that is that I saw something when I was just going through here to where we have brown wires right here. Look at these. Do you see how this is marked BCAN, and they're brown and white? Okay, now the brown and white wires are going to a bus structure, and you could get really confused on this. Don't get confused. Always look at the designations of what they are. A BCAN is a medium speed bus. Now notice how it comes over. I've got a bunch of brown whites, and then the brown white bridges to a bridge, and then they're going to other low speed, and not low speed, medium speed. BCAN is a medium speed. And so then it's coming up here. But if I only looked at brown-white wiring, I might think that these are on the bus that I'm dealing with, and they are not. So just be really careful when you're looking through these and you follow the designations out correctly. So what I'm interested in right now is getting into this instrument cluster with a scope. So that's what we're going to do. Let's go ahead and get into that now. The battery in this Genesis is in the trunk. So I want to go ahead and I want to put a battery maintainer on this car so we make sure that we have good power while we're working on the car, because we really don't know how long this is going to take. And then I want to go ahead and I want to put my scope ground at the battery negative for proper voltage testing. Here we are at the back of the dash, and I've gotten access into the main connector of the dash. The yellow and red, channel 1 and 2, are on CAN C. The green and blue, channel 3 and 4, are in CAN B. So these are two different bus structures. One is high speed, one is medium speed. Now let's go ahead and look at those waveforms so we can try to figure out what's going on with this vehicle. We're into the dash with the scope, so let's go ahead and get the scope, and let's go ahead and bring up some data. Okay, so here's the data. I can already see the problem is on the CAN C. So the yellow red is CAN C. We're going to come back to that. First, let's just take a quick look at these messaging right here. These messages, you can see each one of these are packets of data. And the way that this system is working is I have a voltage differential scheme. That means that I have 5 volts going to 1 volt, and I got 0 volts going to 4 volts. And when one goes high, one goes low. And when you put these through a twisted pair of wire, this differential voltage will reduce the amount of emissions that are being put out from a wire. Anytime you have really fast edging and the edges are changing within a wire structure, it's going to have radio emissions. Now, we don't want the radio emissions entering other wires and other systems. So the way to reduce those emissions is to have a differential voltage scheme on a twisted pair of wire. In this case, the twisted pair and the dual or the differential voltage scheme will help where I don't produce output, but the twisted pair also helps eliminate input, like something else putting into this wire to where we would have some type of a communication issue. So that's what's going on here with these. Now let's go ahead and look at this, because this is where my problem is. This is CAN C. Now we might think that that's communications. Guys, that is not communications. There is no packet of data there. What this is noise. First off, notice that I'm at a zero plane. Second off, notice that I can have a yellow rise with a red fall, and that means that these wires are not grounded together. Since I'm having two differential potentials and I can see them, these two wires, the twisted pair, aren't shorted together. And then I have a voltage that's going below ground and one that's going above. Now this is just noise. This is not a CAN data pack. So we have a CAN C failure. There's no question about that. So now we have a problem. And we can see this continuously across the bus structure. We're at a zero plane going up and down, and these are not packets of data. All this is noise. So that's what's wrong. This is down. This looks to me like one of the modules has failed, and the module's transceiver has a failure, and it's causing this data problem. And you can't transmit data when we don't make good zeros and ones, or good voltage high and voltage low, which is a Boolean code, so we can send data across the wire median. So this is definitely a problem. So we have a module bad on the car, so now we're going to need to find it. And that always gets to be more complicated because I just looked at how many modules are on this. So if we go back over here, we got a lot of modules here. So now these wiring split outs are going to become really important. So we can see where these wires come in here and they come up into here. And so these are the junctions. And when we look at these junctions right here, so we went out here and we come into these modules, and these are all pretty easily, I can access most of these to directly unplug them if I needed to. And then these wires are fed back out, and when they're fed back out, they come back in right here and they go down, and now they go into a connector, and this connector is going to go to the rear parking brake, and it's going to go to the smart cruise control, and then these two wires go out and they go down here and cross, and then they come in here and they break out and they break out, and now we start to have all kinds of modules that are going to come off of the system, and it's going to feed a bunch of different modules off of these other connectors. So what I want to do is I need to find this connector, because this connector is going to break that main bus apart from the front of the bus and these modules right here, and it will break it away from these modules. So then this is going to be a really good connector. So this is this JE04. Now, I'm not sure where that connector is, or that splice pack, but they always put these splice packs where they're accessible. They're somewhere on the car where you can get to them easier than taking everything out of the dash, because I sure don't want to do that until I know which module I'm looking for. So the first thing I'm going to do is I need to go and do a little work, and I need to find out where this connector is. And sometimes to find these connectors is not easy. So let me go see if I can find the connector and see what we can do, and then we're going to take a look at disconnecting it wherever it is on the car, and then we can try to figure out where my problem is on the car. But one of the modules is bad on this car. So I'll be right back once I figure out where these connectors are on this vehicle. Okay, to find these connectors has been a real problem. I mean, this is not some easy thing to find. So what I ended up doing is I sent an email into Mitchell, they sent me back the diagrams of all kinds of connectors, 12 pages worth. But I can see the connectors that we're needing to work with. And right here we have this connector, and this is the JE04 connector, and we can see the horn right here, and that connector is right here. Now that connector is this one right here, the JE04 connector. So I know where that one is now. So I want to go disconnect that connector, and I want to see what happens to the bus. So let's go ahead and do that. Okay, so I've located the connector. Here's our horn, and here's the connector that we're worried about. So I've got it disconnected. Now the scope came up. So okay, I want to show you something else here. Do you see how we have a high speed, brown and white, and we have a low speed or a mid speed in the orange and blue? Those wires were not shown on the wiring diagram. But this is definitely the connector for the high speed, but something's not quite right with the diagram, and I can see that right here. Let's go ahead and go in and take a look at the scope. Now we've got the scope. Let's go ahead and get some data on the scope. So now we can see by unplugging that connector that we now have CAN and we have communication packets that are going on here. And so what we've got is we can clearly see we're at 2.5 on the bias, and we have the rising and the falling. And again, this is a voltage differential scheme, and again, this is to limit the radiation effect out of the wiring. So that's really what's going on here, and we're good to go here. So now we know that the bus is back up and operational. So now we know that when we disconnected that splice pack, that something off of that pack is pulling the bus down. So we've isolated that from the rest of the bus. So now is what I need to do is we need to go back over and we need to look at this. So we came into this is the connector we disconnected right here. And right away, I can see that we have this front radar. Now this car was hit in the front and the rear. So I'm thinking maybe that radar might be bad. So I want to go ahead and I want to plug this back together, and I want to make sure that the bus is still failing. Always, once you've disconnected anything and you're reconnecting it, you got to look at the scope to make sure that your problem is still present. Sometimes I disconnect things and I reconnect them and it's fixed. Now usually with splice packs, it stays broken, but when you unplug modules, a lot of times the module will work after it's been repowered. And if that is the case, you're going to have to cycle the ignition and you're going to have to try to get it to fail again so you're sure of where my failure is. Right now, we know that something off of that pack definitely has the problem. Now we're on the dash, and the dash is way down in the system. So now, I want to plug that in, and I want to make sure my bus fails again. And once it fails, then I want to try this to disconnect this smart cruise in the front just because it was hit in the front. And then then is what I want to do is, since this one goes back and feeds a big portion of the bus, I need to find this one, this JF10. So if I unplug this, and the bus is still down, if it comes up, that's what's wrong, and it was hit in the front. If it comes back up, I want to take this off, and then this is going to take off part of the other circuit. So we're going to use these jumpers to isolate different portions of the circuit. So right now, the first thing I want to do is plug this in, and I want to make sure the bus is still bad. So let's go ahead and take care of that. Now, as we can see, they've been fixing the front. The front and the rear bumpers are off of this car. Apparently it was hit in both ends. But this, since it was in front, I just want to make sure that this isn't my problem. So let's go ahead and disconnect this radar unit. Okay, so the scope still is pulled down, so that is not my problem. Always reconnect what you've unplugged so we don't have another problem. You can actually create problems by leaving the stuff unterminated, and you can start a bus ringing when you get enough of these unplugged. So we only do one at a time, and we're going to replug it in. The radar is not my problem right now, so let's go ahead and let's find that other connector wherever it is, so I can separate that portion of the bus to see what's going on. Okay, so I've found the other connector, and it's right here, this JF10 joint connector. And you can see right here, this module, that's the rear parking brake module. And then we've got a brake off, and we can see that this connector is right on top of the subframe. So that's the connector that I need to go find under the car. And when we disconnect that, then it will give me a better idea of where the failure is in this vehicle, because there's still a lot of modules in this car. So this is just going to take a little time, and we're going to go connector by connector until we can figure out what's going on. Okay, here's the connector right here that we're looking for. You would never find this connector without that guide. It's sitting up on top of the subframe. Even with the guide, I had a hard time finding it. So now is what we want to do is we want to go ahead and pop this. Okay, so the scope came up. So this is the electronic parking brake module, and it is above the rear differential housing in the subframe. Now you can't touch the connector on this, so I can't disconnect this. Not very easily. I'm going to have to remove the rear differential assembly or the subframe in order to get access. So I've got this connector right here, and what I'm going to do is I'm going to bridge these wires, and I'm going to leave these wires off, and when we bridge these, we'll be able to make sure that this is the one that's the failure that goes over to this module. Let's go ahead and get those bridged. Here's the CAN splice pack for the electronic brake control module in the rear. I've gone ahead and I've bridged it, and we've just taken out the bridge that would go to the brake module, and I've got it connected to the main bus. So if the scope shows a good waveform, the electronic brake control module is my problem. So we've unplugged the connector, and I've gone ahead and I've bridged that connector as well. So now the rest of the bus is reconnected, and the only thing that I've got off of that connector is the parking brake control module. So now we can see that we have a good bus. So if we come in here and we look at the bus, it's fine. These are my data packs. We're making good data. So that's not the problem. So the way that this works is the bus is up and functional now. The problem is the parking brake module, and that's going to have to be replaced. And when the shop pulls down the subframe and the rear end where we have access to that piece, they're going to need to check the powers and grounds to make sure that the module has proper current, because the module can't work without current. Once the current is, the power and ground is good, then is what we'll do is they're going to need to put the module in, and then this vehicle is going to be ready to return to the customer. What I really want you to take away from this is the event-driven diagnostics. When you do event-driven diagnostics, you have to have an idea of why you're doing the test. You have to understand the data, and then that data will drive the next test. Understand each test and why you're testing it and what the data you acquired would mean. In this way, you'll always come out and you'll find the problems with the car very rapidly. You also need to have really good equipment, and if you follow this game plan, you too will have good troubleshooting in your base.